A very good day to everyone. This is Prakash from Team SWTID 2026-3095, which is led by the team leader Waka Venkatesh, and the remaining members are 29 is Saikrishna Chowdhury and Yara Vivek. Today I'm here to demonstrate my project, which is credit card approval system. Uh, the model or the system which automatically analyzes the credit card application, and based on the parameters that the customer applied, the system either rejects or approves the credit card approval. So in this way the system works. Let us dive into the project a demonstration. Here we can see in VS Code I have opened my project folder. I have created the folder as a credit card approval prediction IPYNB. There are several modules over here, such as .venv, venv1, venv2, app, data, docs module, etc. Uh, uh, if we start with app module, here we have uh, app.py file, which contains the main app code, which is written in the Python and followed by the rules.py. And yeah, in data module, we have data sets, which are main and heart of the uh, system that we are working on. These data module contains the data sets, which are application record.csv, credit record.csv. These two more data sets contain the data of the customers, and based on these two data sets, the model learned properly. So here we have again another section called docs, and here the module of model which we have used in this project, which is best model.pkl. And the king of the show here, it is the credit card approval prediction notebook. If we come to here, this is the main code that we have written. This is the main notebook that we have written to build the project. There are several steps in this credit card approval prediction system. Nearly 14 to 15 steps are there. Let us go through the each step. If we start with the yeah, the first step is creating and activating a virtual environment. It will be optional, or we can do without the environment, or we can also do within the environment. We need to install the dependencies such as NumPy, Pandas, Matplotlib, Cbon, Scikit, etc., XGBoost, Zolibs, SciP. Uh, Based on this, the model or the system going to work. And here is the step two. The step two is mainly regarding the loading the data set. In this step, we load the required data sets. The application data set contains customer details, while the credit card record data set contains their repayment history. These two data sets form the foundation of our prediction model. And here is the step three, which is the importing the libraries. Here we import all the necessary Python libraries. Pandas and NumPys are used for data manipulation, Matplotlib and Seaborn for visualization, and remaining for the machine learning models. And here is the code regarding the step 3. And if you dive into the step 4, there are several things. Uh, we read both data sets in the pandas, data frames, and inspect their structure, data types, and basic statistics to understand and available information before pre-processing. All these things are happens in the takes place in the step 4. And here is the step 5, which is univariate analysis. Here we perform univariate analysis by examining each feature individually. This helps us understand the distribution of numerical and categorical variable and identify any unusual values. In this way, the step 5 works. And if we go forward, here it arrives the step 6, which is multivariate analysis. In step 5, we have seen univariate analysis, and here step 6, it's a multivariate analysis. In this step, we analyze the relationships between different features using visualization. This helps us identify patterns and correlations that may influence the credit card approval system. It has also various things or various cells such as income versus education type, income versus income type, gender parameters, family status parameters, age parameters taking. All this happens in the step 6, which are called multivariate analysis. And if we go forward, we will be in step 7, which is a descriptive analysis. Descriptive analysis. Here we generate descriptive statistics, which check feature distributions, measure skewness, identify missing values, and detect duplicate records to assess the overall quality of the data sets. And all these things happens in the step 7. And if you go to step 8, it's about drop duplicate features. Uh, since the duplicate records can affect model performance, we identify duplicate applicant entities and remove them while preserving the original information. All this happens and the data cleaning or data processing will be takes place in step 8 too. So if we go forward, here is step 9, which handles the missing value, which is also the part of the pre-processing of the data. In this step, we analyze missing values and apply suitable techniques to handle them, ensuring the data set is complete and ready for model training. And the step 10 is about data cleaning and merging. Data cleaning and merging. Now we can clean the data and merge the application data set with a credit history data set to create a single consolidated data set containing all the relevant information. All this happens in step 10. Uh, if we here we can also see that aggregative credit record CSV applicant, did they ever hit status 2 or worse, and based on those conditions, the status 2 comma 3 comma 4 uh, runs or executes, and based on the other condition, the another condition will be executed. And this is how the step 10 works. And if we go to step 11, it is about a feature engineering, a feature selection, or an attribute selection. Here we create additional meaningful features such as income per family member and digital engagement score, which help the model learn better patterns from the data. And this step 11 is one of the important step over the all the cells and over all the steps, because here it is it runs about feature engineering, which generates a new attributes or new features which will enhance the accuracy of our output of the model. So this is how the step 11 works. And coming to the step 12, there are several things that have to evaluate. The steps 12, it handles about the category values. Machine learning algorithms require numerical input, so we convert categorical variable into numerical representations using encoding techniques. And here there are several points separating binary flag from multi-category features, encoding binary columns, one hot encoding multi-column category columns, confirm no object or category column remain. Everything should be numerical now. All these steps are involved in and final feature target split ready for modeling. All these steps are the part of the handling the categorical values, which is a part of a step 12. And now it's step 13, which it deals about the logistic regression model. Here, our first machine learning model is logistic regression. It serves as a baseline model, allowing us to evaluate the initial prediction performance. And this is about the step 13 and logistic regression model. You can clearly see the code that we have written here. And it also contains the five more sub topics or five more sub cells in the step 13. And coming to our second model, which is random forest model, step 14. Next, we train a random forest classifier, which combines multiple decision trees to improve prediction accuracy and reduce overfitting. And in this way, the step 14 will be executed to produce the enhanced output or accurate output, because the random forest will increase the accuracy of the output so that the model can learn and perform efficiently or effectively. And here, the step 15, which is a decision tree model. Here we build a decision tree model which provides an easily interpretable prediction process and helps us understand how different features influences the final decision. And this is how the step 15 works. And if we go through, while here we can see the XGBoost model, uh, which is not a part of the steps, but here it have the its own representation or its own value. Um, we implement the XGBoost classifier, which is an advanced gradient boosting algorithm known for its high accuracy and efficiency. This becomes our primary prediction model. So XGBoost here, it is used a lot to predict the output and to make the system efficient. And coming to model comparison, which is the most important thing, after training all models, we compare the performance using the evaluation metrics such as accuracy, precision, recall, F1 score, and ROC. They use it to identify the best performing model. Here, there are several steps again, which are efficiency step one, which deals with the stratified k-folded baseline, and step two deals with the hyperparameter tuning. Uh, to further improve the performance, we optimize the XGBoost model using hyperparameter tuning. This helps achieve better prediction accuracy and improves generalization. All these things takes place in the hyperparameter tuning and model comparison. The comparison of the models can represents the or can show the efficient or efficiency of the each model that we have used in this project. And this is how the project works, and this is how the credit card approval prediction a notebook of Jupyter variable notebook uh, has been written. And if we see the demonstration, let us open the terminal. Yeah, here I have already opened the terminal. Yeah, let us run this project. First of all, cd space app, so that we can go to the directory of the app. Now let us run. Pardon me. Now, let us run the project. Which is the command is Python space app.py to run the project. Uh, it seems like we have got an error. The term Python not recognized. My bad. I have written the wrong spelling. Yeah, here we can see. Yeah, here we got the port number, which is used to uh, run our application or run our system. I copied that and I have opened my Chrome browser, and here I am running. Yeah, here we can see the demonstration of our model, which is just demonstrated with a basic front end. The credit risk desk. We name this platform called credit risk desk, even though our project name is a credit card approval system. As the front end, we need to display something, so we just named it as credit risk desk. Uh, with a more to a second pair of eyes for every application, never the only one. So let us see how the model works and how can it evaluates the applicant. If we click the screen the applicant, we can here we will be provided with a detailed form which contains the identity and household and financial standings and contact details of the file or a person. So here each section we have several things that we have to uh, give. In gender, I have selected female, and let us give the age 35, and family status civil marriage, or we can make it as married. Family members, let us make it as four. Number of children, let us make it as two. Housing, just be let it be a rented apartment. And coming to the final financial standing, annual incoming, let's give 2 lakh. I hope it's right. 2 lakh. And incoming Yeah, income type, which is working. Yeah, let's keep it at working. And occupation, there are several occupations that we have provided: core staff, cleaning staff, cooking staff, accountants, medical staff, not employed, private, uh, realty agents, sales staff. I just want to go with the core staff. And years of employed, it's regarding the experience. Let us give the experience of 5 years. Owns a car, no. Owns a property, let us be it as S. Yes, let us be it as S. And education level, higher education, as they are core staff. So coming to, we can select either of these three, uh, which are work phone or phone or email. Let us give the phone. Yeah, no need of work phone. Run risk screening. Yeah, clear. As I have just selected the a female, a core staff who's age 35, who earns 2 lakhs yearly, uh, is who does not have any financial risks. So the model predicts that clear, no elevated risk, flat. So what's driving the score? Car ownership increases the eliminated risk. Employment status increases the eliminated risk. Contact details and the files increases eliminated estimated risk. And income per family member lowest estimated risk. House type rented apartment lowest estimated risk. So in this way, uh, the model predicts the estimated risk is just a 0.9%. So the model predicted it as clear, no elevated risk, a flat. So if we want to screen another applicant, we can click there, and we can again give the another details, so that the model predicts. So this is how the project works. I mean, the model works. The model just builds everything. I mean, the model takes the input from the applicant, and it evaluates each and every parameter, such as identity and household, financial standings of the applicant, or contact details on the file that the applicant provided. Based on all these parameters, the model evaluates, and it gives the accurate output, whether the person is eligible to go get the credit card, or whether the person is not eligible to get the credit card. So it is a uh, it is an important thing, or which is a useful thing, uh, that banks can adopt, because checking the because banks can get n number of applicants every day, or every month, or every week. So it will be impossible to bank to go through all the applications manually, and check their details, or check their transaction details, or they checking their civil score, etc., etc., to approve the credit card. It will be a time taking process, and it is too much risky. So here is our project called credit card approval system, or credit risk desk, which is very useful to reduce the manual verification of the bankers or bank employees to approve the credit card. So the models reduces the manpower and reduces time, and it just uh, gives the output, or it just verifies the applicant application within minutes or within seconds. So that's it, guy. That's it. That's about our project. This is how the credit card approval prediction system works. And yeah, here we can see everything was stored here properly. And I'm going to terminate the process. Yeah, that's it. That's it for the project. Uh, yeah, this is about the demonstration of the credit card approval prediction. Thank you. Thank you for this opportunity. Have a good day.